Okay, so let's do this one more time. This one is a little tricky because the leading coefficient now is 2. So this changes things a little bit. All right, so we're going to start out exactly the same way. I'm going to rewrite my equation, j of x equals, and I'm going to group my x terms, 2x squared plus 16x. I'm going to leave some space in there, and then plus 29. But before I try to complete the square though, I have to do an adjusting. I have to do something to adjust. I can't just start with this and build the square. The reason why is because when we start building our square, we'll hit a problem with our x squared term. If I went and I put a 2x squared here, and then I tried to factor the edges, 2x and x, I would have not matching sides, like the sides wouldn't match. So I can't put a 2x squared in there. I can only put a perfect square in there, which would have to be an x squared without the 2. So what I need to do is a little manipulation where I actually factor the 2 out of this set of parentheses, out of the x terms. So I have to rewrite this one more time, j of x equals, and now I'm going to take the 2 out. I'm going to put the 2 out front and see what's left. But remember, now we're in parentheses. I have to divide the 2 out of this term and this term. So 16 divided by 2 is 8. So I'd have 8x. And now inside the parentheses, I have what I need to complete the square. So now I'm going to use those numbers. So x squared and 8x. So I'll put an x squared in here. That's a perfect square. I'm going to divide the 8x in half and put 4x here and 4x here. And then get my edge lengths. And this time they'll match. See, we have x by x makes x squared, positive 4, positive 4. And now this means that the number that will complete my square is 16. So I do add 16 in here, but I'm going to have to be really careful in this next step. I'm technically not adding 16 to this equation. I'm adding 16 times 2 because the 2 would distribute in to the parentheses. So technically what I'm adding is 32, which means to keep this balanced, I need to subtract 32 or subtract 16 times 2. So now I have what I need to finish this problem. So I'm going to rewrite this part as x plus 4 squared. So now my function will look like j of x equals 2 times x plus 4 squared. There's our perfect square. And then 29 minus 32 makes minus 3. All right. This is our vertex form, so it's done. Now I just need to identify my H, K, and A. So look at this now, our A is 2. This tells me that the size and shape of my graph will be twice as steep as a normal parent function of a quadratic. Here I have K equal to -4, and here I have, oops, wow, brain, H equal to -4, sorry about that, and K equal to -3. And then that means our vertex is at -4, -3. So I'm going to go ahead and graph this, -4, -3. And now when you build the rest of your parabola, you just need to remember to go twice as steep as normal. So instead of right one, up 1, you go right 1, up 2, left 1, up 2. And instead of right 2, up 4, you go right 2, up 8. So not 4, but 8. And then balance it on the other side, left 2, up 8. And here's our steep parabola with vertex at -4, -3.